Hello, everyone. Welcome to today's next video build workshop. Today we have two workshops back to back from 4 till 5:30 UK time. But our first workshop is with Luc from ENS, who's going to be giving a workshop on ENS Identity in your dApps. Before we jump into the workshop, just have to say a couple of quick things. Firstly, just to introduce myself, I'm Jamie, the program manager for the hackathon for the next video build. And secondly, we're just going to be posting a couple of links in the chat now to some helpful resources to get you started with the hackathon. The most important one being the Hacker Pack, which has all the resources and links you need. And it also has a link to my Calendly if you feel like a one-to-one call would be useful. I can try and support you with any way that would be useful for you. So if that's great, if that would be useful for you, then feel free to sign up for a call. Without further ado, we will get on with the workshop. So I will hand things over to Luc to get going. So over to you.
Hi there, my name's Luc. I'm 0x225 F1371270D90677788. 314 BC 7FCC 1F36746A3 C3B5 or Luke.computer for short, or Luisman.eth. Regardless, that right there is the core premise of ENS. ENS is the Ethereum Name Service. ENS is the ability, or at least provides the ability, to convert human readable names like nick.eth into machine-readable addresses like 0xb8, C2, C29, etc., etc. I'll spare you the pain. And backwards. So we can also convert from addresses to human-readable names. Now, this means that all of these web UIs, where it shows 0x225, your address in the top right, are now simply just this, Luc.computer. So before you run off, please stay in the call for a little bit longer. And let me show you some of the talking points that I'll be covering during this presentation. So in no particular order, here we go. I'm going to talk about what ENS actually is and how it works under the hood, the DNS integration that we currently have and what's happening there and how it works, records and resolvers and the way that we can store values with names, cross-chain interoperability, and the ability to have things on different chains and all sorts of other fancy stuff, how to get started with implementing, getting your first ENS, and all those kinds of fun things. So before doing all that, some milestones real quick. We recently hit 2.75 million names registered. We have about 506 official integrations that I have one-to-one contact with, and that we can help out whenever they have issues. So if your project does end up becoming super big and you think, oh, shoot, we need somebody from ENS to help us out, then hit me up and I'll happily add you to that list of group chats. 593,000 different people have ENS names associated, like unique wallets, essentially. So let's talk about a quick practical example. In your average dApp, and I'm going to use Tic-Tac-Toe, my weird hackathon project that I worked on for ETH Paris, ETHCC, is just simply a tic-tac-toe game in Solidity. It's nothing fancy. Let's not talk about the UI. It was made in like 4 or 5 hours. But if you look right there in the top right corner, it says v3x.eth, which is yet another name that I have. I need to be more consistent with my screenshots. Long story short, my name now shows up in the top right, and it works. It's that easy. Simply names across the entire ecosystem. So now, obviously, there's more functionality to it. We can do some reverse lookup stuff. Let's try that out. So when you go here, you obviously create a game. So you press the game button. And then in the opponent field, you can either fill in an address of whoever you want to play with, or you fill in their ENS name. In this case, nick.eth. Got it right there. And right underneath, you can see his profile picture show up. So I can confirm that it's Nick, as well as the beginning and the end of his address. Sweet. So we know we're dealing with the right one. Let's send them an invite. Now, here's my tic-tac-toe game, right? That would be super cool. I would show you my victorious beating Nick, which, we're not going to talk about my tic-tac-toe skills. But regardless, you get the idea, right? My name shows up, his name shows up. You can see the moves that we've made. Our profile pictures show up, and everything beautifully works. So that's it. The core idea, ENS. For this dApp specifically, provided the username and the profile picture. And that looks around about like this. So Luceman.eth, which is my primary name. You can swap around which name you use as your primary name, and your address. The address is really like your user ID, basically. But we also store a whole lot more data than this, because you see the cute profile picture, right? The way ENS is set up is we allow you to store key value pairs associated with names. So for Nick.eth, we're not just storing the profile picture, we're storing his Ethereum address, we're storing his Doge address, because yes, Doge address, his Bitcoin address, his Litecoin address, the website, the email, Discord, Twitter, Reddit, Telegram, GitHub, ENS delegation link, and the avatar, which can either be an HTTPS link, an IPFS link, an HTTP link, in this case, EIP 155, so a way to link to NFT pictures on a certain chain, and a whole lot of cool stuff more. So the big question is, how does this actually work? ENS has a ton of little smart contracts. One of the core contracts looks around about like this, and the data that it stores is very simple. For every name, it stores the name, makes sense. The registrant, 0x225, F1373, okay, that. When it expires, November 18th in this case, 2025, and the resolver, an address where it can go to fetch the key value pair information. So it stores that for me, it stores that for Nick, it stores it for Vitalik, and it stores it for everybody else who has an ENS name. So when I go to the front end and I go, hey, I'm looking for Nick.eth, then the front end will say, okay, yeah, this record right here. And then I go, I need to know Nick's avatar. So we go to the resolver address, we reach out to it. It is a smart contract. In this case, this is the public resolver. And then this smart contract returns all of the key value pairs that we were asking about. So if I ask for the Ethereum address, I'll get the Ethereum address. If I ask for the avatar field, I'll get the avatar field. Sweet. This is the public resolver, like I just said. It's basically one smart contract we've written that allows the authorized owner of a name to store their records there. So you can use the public resolver to store all your fun key value pair records and edit them. But if you didn't want to use this, you can use your own contract. So instead of using the public resolver, you deploy your own contract, and your contract might return this as information. And you can have an avatar that changes depending on your current portfolio value or the day of the week or all sorts of weird fun things like that. Sweet. So that's ENS in a nutshell, the smart contract side of things. Looking up things, loading things, and names works perfect. But I can see you sitting out there and going, yeah, but I want to mess with the fancy shiny stuff. I want to build on all these, cool things, all the fancy things, the Polygon, the Optimism, the Gnosis, the Arbitrum, BNB, and all that fun stuff. The Binance Smart Chain. And you sit there and you go, yeah, I want to do these things. Well, can I do this with ENS? Well, I've got good news for you. We've got the Cross-Chain Interoperability Protocol, a whole mouthful of words, CCIP for short. And CCIP is a set of specifications that were written that allow us to, from a tooling perspective, load information from the chain, from ETH mainnet, and have ETH mainnet then tell us, oh no, you need to be over there. You got to be on Optimism to read this, or you got to call that smart contract. So that allows us to have data off-chain, on-chain, off-chain, on rollups, on layer 2s, using zero knowledge somewhere, using HTTP, available over HTTP/CP if that's your type, on your toaster or wherever else you might want it running, right? Resolve everywhere. So how does this work under the hood? You have your library on the front end, right here on the left. And this library makes a call to ETH mainnet. So it goes up here, it goes to the ENS contract, it gets that resolver that I just showed, right? It goes to the contract, and the contract then reverts with off-chain data. It calls off-chain data. It gives you a location like here on Optimism, you got to go, and it gives you the address. And it tells you run this function and give it this call data. So that's what happens. The library says, oh shoot, we reverted with an off-chain data error. And then it goes out there to Optimism and it says, hey, Optimism, I'm looking for this contract. This is the data I want to call it with. Please give me. And then Optimism will reply accordingly and output the data. So if you have subdomains, or if you have your records, right, your avatar, your current bio, or your Discord on an L2 or off-chain with HTTP, you can have it fetched this way. Super cool. So an example of one of these things is twitter.ngo. And I'm going to have to add to this. This works all the behind the scenes. And from a front-end developer experience or from a mobile developer experience, you won't notice a thing. This is all beautifully enabled as long as you have the latest version of Ethers. So twitter.ngo, it was a fun little clever hack where anybody who has an ENS name in their Twitter name now also has a subdomain of twitter.ngo. So if you go to loosemansnl.twitter.ngo on any ENS enabled application, then it will show you my address, my Twitter profile picture, and all that fun stuff. My Twitter bio. Example here with Nick. So Nick SD Johnson.twitter.ngo shows the address, shows the Twitter URL, shows an avatar, shows etc. It's pretty funny. I don't know. I thought I'd build it. So next, let's talk about libraries. There's a ton of libraries out there. Here's a whole bunch of them, and all of them already support CCIP, and all of them support ENS from the get-go. So if you're using Ethers, if you're using ENS.js, if you're using WAGMI for easy React hooks for almost everything out there, then ENS is already available. Examples, forward resolution, so converting from a name to an address, is super easily doable. Provider.resolve name with Ethers, or use ENS address, the React hook with WAGMI. And then you give it the address you're looking for, and it outputs you the name. Sweet. And as well, reverse resolution. So given an address, tell me what the name is. Tell me what the avatar is, and otherwise it returns the address again. So use ENS name, you feed it the address of the user that's signed in, and then the output you get is v3x.eth or 0x225f13, etc. And a whole lot more. It's super cool, and I haven't even had a time to talk about subdomains yet, which can also be controlled by resolvers. You can do fun things like admin.luke.computer and like all these other cool things. In addition to all the above, Luke.computer is the DNS name, and you can import any .com, .io, .xyz, or any other valid Web2 domain name and use it as your ENS name, or just get a .eth somewhere. App ENS Manager. So if you have any more questions, we have a documentation out there. It's docs.ens.domains. There's a whole bunch of cool stuff in there and a couple guides and all sorts of things like that. And yeah, if you are sitting here right now and you're going, wow, that's pretty cool. I want one of these. How do I register? It's pretty simple. You go to the ENS Manager or to any of the other fancy fun applications. The ENS Ferry to give names to other people. The Rainbow, which is a mobile app, mobile wallet that has ENS built in. Coinbase hands out subdomains for CBID. Any lens name is a valid ENS name by adding .xyz behind it. So loosemans.lens.xyz. And Argent also hands out names with argent.xyz subdomains. We have the alpha coming out because fancy stuff. This is our new manager. Woo, should be out soon. Currently on alpha ENS domains, limited to Gorley. So yes, you go to the ENS Manager. You get there. It looks roundabout like this. Pretty easy. There's a big search bar. So we click on the search bar. We type in whatever name we're looking for. Alice.eth in this case. Then if the name is still available, it shows us our lovely registration screen. Names 5 characters or longer are $5 a year. That's it. In ETH, you click next. You go through a commit reveal process. So it's 2 different transactions, waiting 60 seconds in between. And then voila, there's your ENS name. This is from the manager, from the new one. Super cool. And it works. So how do you go about setting your avatar, right? Remember that whole public resolver thing? All built into the UI. So you go to the page. You on the right side right here, you click on add or edit records for your alice.eth name. You click it, you set your avatar record to HTTP or to an IPFS link or to an Arweave link or any of the fun stuff. And then right there, that's your profile picture. Done. Easy. So before I finish this presentation, I have one last thing to do. Yes, there we go. If you want to reach out to me, loosemans.eth, luke.computer, v3x.eth, or any of the above. If you go to luke.contact, you'll also find me. I'm loosemansnl on Twitter. I'm working on a bunch of other cool stuff at the same time as well. But if you have any more questions or if you want some additional help, hit me up and I'll happily help you out. And yeah, happy hacking.
Thank you very much. That was a really great presentation, and I'm sure you've inspired people to use ENS as part of the hackathon. We do have some time for some questions, so feel free, guys, to write those in the chat, or you can ask it live. I will get us going while people, to give people some time to write their questions. I would ask, what are your top tips for using ENS for the first time?
Yeah, so most Web3 projects these days, at least, are built with React. So I definitely would recommend giving WAGMI a shot. It allows you to basically use ethers, but use through React hooks. And it has some hooks built in as well. So you can simply just do use ENS name, and then it will magically figure out the account that you're logged into, get its ENS name, and show it to you. If you're using RainbowKit, if you're using Web3 Modal, if you're using ConnectKit, all of them will automatically show your ENS name and show your ENS profile picture. So all you'd have to do is use one of those, and everything's built in already. If you have some way to find users on your platform, simply just make the input field output to a use ENS address function or a name lookup, and then you can, using forward resolution, and then you can get the address from a name. So if you want users to be able to just invite nick.eth and have your code convert it to the address in the background, one line of code right there. It's that easy.
Awesome. And if you were taking part in the next video build hackathon yourself, and were integrating this with Livepeer somehow, what sort of projects would you be building, just to give people some sort of inspirational starting points?
Ooh, that's a good one. I think there's a ton of different applications out there and cool things that you can build. I think ENS obviously is the username space, period. So for usernames all over the place, I would be using ENS. I think there's a ton of different things you can build. I'd have to think a little longer before I could come up with a good project that I'd want to build. But I think there's a lot of cool things you can do. Most modern applications that we use day to day, think YouTube, think Twitter, think Twitch, think TikTok, those kinds of things, don't have Web3 equivalents yet, or they're working on them. So it's an open playing field.
Awesome. Thank you for that. And another question, we have one in the chat from Lucy. How would you use reverse resolution for proof of ownership for accounts?
Yep. Yeah, so the way that you can use reverse resolution to verify, essentially what happens is the reverse registrar lets you set whatever records you like. So I could technically set my primary name to vitalik.eth, but all of the libraries automatically do this for you. You don't actually have to put any thought into this. When you do a reverse name lookup, they also automatically do a forward lookup. So if my record is set to luc.computer, then what will happen is ethers will go out there, read my reverse record for 0x225, see that it's luc.computer, do a forwards resolution on luc.computer, see that it's 0x225, and then say, yep, that is the same user. Therefore, this name has been confirmed and is the correct owner of that account. And that is their name. And if it fails to do so, then it will simply just show the address.
Awesome. Thank you. Yeah, any final questions, guys? Feel free to drop them in the chat. If there are no more questions, I think we will wrap things up slightly early.
Sweet.
Yeah, thank you very much for coming in. That was a great presentation, and hopefully we can see some projects soon. Yeah,
awesome.
Thanks, Luc.
I look forward to it. All right, take care.